Students, welcome back to chemistry class. Today, let us learn the lesson Chemical Effects of Electric Current. We are going to cover the topics today: good conductors of electricity, poor conductors of electricity, checking the conductivity of a material using a conduction tester, checking whether a tester is working or not, testing whether a liquid allows electric current to pass through or not. So let us see what are good conductors and poor conductors. As already you know, the materials which allow electric current to pass through them are good conductors of electricity. Can you say a few examples? Yes, all the metals are good conductors of electricity. So here are some examples: copper, aluminium, you can say different other metals also, gold, platinum, all these are good conductors of electricity. What is meant by poor conductor of electricity? The materials which do not allow electric current to pass through them easily are poor conductors of electricity. Example: rubber, plastic, wood, etc. Next, we have to learn how to check the conductivity of a material using a conduction tester. What is a conduction tester? A conduction tester is a device used to determine whether a substance is a good or poor conductor of electricity. A simple conduction tester has an electric cell and a torch bulb. One terminal of the cell is connected to one terminal of the bulb by a wire. The other terminal of the cell and the bulb have wires which can be brought in contact with the materials to test whether they are good or poor conductors of electricity. So here you can see one terminal of the cell is connected to the one terminal of the bulb. The other terminal of the bulb and the other terminal of the bulb and the other terminal of the battery have wires which are free. Now the free ends of this wire, we can bring the material which is to be tested whether it is a good conductor or poor conductor. So how we'll come to know which is a good conductor and which is a poor conductor? If the material is a good conductor, the bulb glows. You can see here, this is a screwdriver. It has two parts. This is the metallic part and this is the handle which is plastic. So if you are bringing the metallic part in between these two wires, the bulb glows. What does it mean? It means that this metallic part is a good conductor of electricity. And how to check whether it is a bad conductor or a poor conductor of electricity? If the bulb do not glow or does not glow, we can say it is a poor conductor of electricity. Here we can see the plastic part, that means the handle of the screwdriver is brought in between the two wires. So we can see the bulb does not glow. That means this plastic is a bad conductor or poor conductor of electricity. Next, how to test whether a tester is working or not. Here is an activity to explain this. Join the free ends of the tester together for a moment. So, as we have already discussed, this is a tester. The free ends of the tester we have to join together for a moment. This completes the circuit of the tester and the bulb should glow. If you are joining these both ends together, bulb should glow. Suppose the bulb does not glow. What does it mean? What is the reason for that? There may be three reasons. One may be the connections are loose. Other one, the bulb is fused. And one more reason may be the cells are used up. So check that all the connections are tight. If they are tight, then replace the bulb with another bulb. Maybe the bulb is fused here. So replace it with another bulb. After replacing the bulb also, it does not glow means the battery or the cell is used up. So what we have to do? We have to replace the cell with the fresh cells. Now the tester is ready. Next, do liquids conduct electricity? Let us do an activity to understand this. Collect a few small plastic or rubber caps of discarded bottles and clean them. Pour 1 teaspoon of lemon juice or vinegar in one cap. So we have taken plastic or rubber caps of the bottles, and in one of the caps we have taken lemon juice and the other one we have taken vinegar. Now what we have to do? We have to bring the tester over this cap and let the ends of the tester dip into the lemon juice or vinegar. So here we have brought the tester. Our tester has the components: one cell, this is a cell, this is the symbolic representation of the cell, and this is a bulb, the symbolic representation of the bulb. And the tester, free ends of the tester is dipping in the lemon juice. Take care that the ends are not more than 1 centimeter apart. That means the distance between these two terminals should not be more than 1 centimeter, and also they should not be too close. Then, by the same time, do not touch with each other. That means the two terminals of the tester should not be more than 1 centimeter apart, and they should not touch with each other. Now let us see. Does the lemon juice or vinegar, does the bulb glows here? Does the lemon juice or vinegar conduct electricity? So how we can classify this vinegar or lemon juice are as good conductor of electricity or a poor conductor of electricity? So before answering this question, let us see when the bulb glows and when the bulb does not glow. When the liquid between the two ends of the tester allow the electric current to pass, the circuit of the tester becomes complete. The current flows in the circuit and the bulb glows. Suppose the liquid taken here, it allows the current to pass. The circuit is closed here and the bulb glows. When the liquid does not allow the electric current to pass, the circuit of the tester is not complete and the bulb does not glow. So, if the liquid taken here is conducting electricity, the bulb glows. If it does not conduct electricity, the bulb does not glow. Here, in this example, as lemon juice and vinegar allow electric current to pass through them, they are good conductors of electricity. Why the bulb glow when the electric current glows when the electric current passes through it? This is due to the heating effect of electric current. What is meant by heating effect of electric current? When electricity is passed through some materials, a part of electric current is converted into heat energy. That is called heating effect of electric current. So, due to the heating effect of electric current, the filament of the bulb glows. Bulb gets heated up to high temperature and it starts glowing. You know the filament of the bulb is a material called tungsten. And if the electricity is passed through it, this filament gets heated up to a very high temperature and the bulb starts glowing. In some situations, even though the liquid is conducting, the bulb may not glow. What may be the reason? Let us see the reason. If the current through the circuit is too weak, the filament does not get heated sufficiently and it does not glow. So even though the current is passing through the circuit, sometimes the bulb does not glow. What may be the reason? The current is too weak. Why is the current in the circuit weak? So we have seen that metals are very good conductors of electricity. So though a material may conduct So though a material may conduct electricity, it may not conduct it as easily as a metal. As a result, the circuit of the tester may be complete and yet the current through it may be too weak to make the bulb glow. So, like metals, all the material do not conduct the electricity in the same way. So, in such situations, the bulb does not glow because of the passage of very weak current. So, in the next class, we'll discuss to make another type of tester which can detect even a weak current. So, let us revise what we have learned today. We have learned what are good conductors of electricity and their examples. Then, poor conductors of electricity and examples. Then, how to check the conductivity of a material using a conduction tester. Then, how to check whether a tester is working or not. Then also we learn testing whether a liquid allows electric current to pass through or not. Hope you understood today's class. Thank you, children.